All right, let's get started today. Everybody's well. So, as I sort of pointed out in the chat, today and yesterday represent some of the more conceptually challenging material that we'll cover with this semester. So, I really do want to sort of throw the floor open for questions today. Today's lesson is on this sort of big word, right? At this point, in your journey in computer science, we're not we don't have a lot of super complex vocabulary words that we use, but this is one of them. This is maybe the most esoteric or seemingly sort of frightening term that you might come across in this particular course. But it's not really that complex, and it's also something that, like many other things that we do in this class, is I think best understood through examples and through sort of hands-on experience. And so, again, I'll sort of spend some time going through this, but we really sort of begin this with another puzzle. So this is another example where we're looking at something about the Java programming language that, given what we've known so far, shouldn't really make sense to us. So I've created a method here called printed, and the method takes a argument of type capital O object. And in the past, when we've had a method like this, we've had to pass something that was a capital O object. If I have a method that takes an int, I got to pass an int. I can't pass a char or a boolean, right, or a double. There's some cases where Java will cast things for me, right? But in general, when I have a parameter to a method, in the past, I've had to pass an argument that matches the type of the parameter. And so that's kind of what I'm expecting here. I'm expecting that in order to get printed to run, I'm going to have to pass it a capital O object. I create a couple of other classes here just for fun. These are empty, but they're just kind of to add some classes so that we can mess around a little bit. And then I create 3 different objects. So I create an instance of a string, and I'm doing this using the literal sort of syntax. I could also say new string and then use the string constructor. Either one of these works fine. I create a new pet, and I create a new course. Both of those have empty constructors because those class declarations are empty, and I'm really just using those to show you how different objects behave in this particular situation. And then down here, again, so far to us, this really shouldn't make any sense. I'm calling printed with 3 different arguments. The first one is a string. We created that on line 7. The second one is an int. A pet. We created that on line 8. The third one is a course. We created that on line 9. None of those matches the type of the argument that printed expects to receive. String is not an object, course is not an object, pet is not an object. And yet when I run this code, is that they'll work. And in fact, I can print all of them. And they print a little bit differently, you'll see. But I'm allowed to pass all of them to that method. And so on some level, this sort of, albeit somewhat trivial and small example, really contains all of the seeds of this particular idea. Because what we're seeing here is polymorphism. So the word itself, a literal sort of unpacking of that word, poly means multiple. I'm trying to think. Polyrhythm, a piece of music that has multiple different rhythmic signatures associated with it. Polymath is a person that knows a lot of different things. Polygon, something with multiple sides. So this is a prefix that indicates multiple. Morph, right? What does it mean to morph? Change, to shift, right? I can, if I was in some sci-fi movie, I could, morph into some other type of shape or creature or whatever, right? It really means to change. Morphology is the study of change of a particular kind, right? And so what this reflects in particular object-oriented programming languages is the ability for an instance of a particular class to morph into something else, to appear at a particular point in the program like something else. And we see that here because, again, this, in order to run, this method requires that I pass it a capital O object. I never passed it a capital O object. I could create a capital O object. We can actually do this, right? We can say is equal to new object and do that, and then I could pass that to print it, and that would also work. But none of these other instances that I've created are instances of capital O object. It's an instance of a string. It's an instance of a pet. It's an instance of a course. So the fact that I can pass them to this method means that all three of these are capable of acting like an object, morphing into an object. And so the string can act like a string. The string will have string methods like length and stuff like that, split, other things. So it can act like a string, but at a certain point in the program, it can also act or morph into an object. And the rest of today's lesson is really kind of just focused on understanding under what circumstances this can happen. What are the rules regarding, when this can actually take place and stuff like that. And this is also connected to the concept of inheritance. Now, polymorphism itself is actually a much broader idea. What we're looking at is a particular type of polymorphism. We're going to look at, we've actually already seen another type of polymorphism, and we come back and we'll see a third type later in the class, and we'll sort of at that point connect the dots a little bit and talk about every type of polymorphism that we've seen. But there's a video here that goes a little bit through the Wikipedia definition, which is kind of at a higher level of abstraction than we're even talking here, right? We're talking about a concrete example of polymorphism in a particular context, which is in Java, under certain circumstances, an instance of an object, an instance of a particular class can behave like instances of other classes. And morph into instances of other classes. But again, there's multiple different ways in which polymorphism emerges in different programming languages. This is one example, right? This is sometimes, well, I shouldn't say sometimes known. This is known as a subtype of polymorphism. It's a one particular example of this, but there are others, and we'll see them, again later. But for now, what we're going to focus on is subtype polymorphism. So, now that we've seen an example of how a particular object can behave or can morph into an instance of a different class. Now we need to kind of figure out what are the rules surrounding this? What are, when can this happen, and in what points of the program can this take place? And what type of objects, what type of other classes can an instance of a particular class morph into, right? That's the other thing that we need to figure out. There's this idea, you'll see this in, in the literature of this sort of is a relationship, right? And understanding this is the key to understanding, the rules behind subtype polymorphism, right? So really, given a particular instance of a class, there are one or more, usually, other classes that we can say this instance is a whatever. And this connects us back with yesterday's lesson because this is connected to inheritance. So when a class extends another class, this is sometimes known as substitutability, I can consider an instance of the subtype also as an instance of its superclass or its parent. I can consider an instance of the child as an instance of the parent. Now, if I don't extend another class, we just saw this in action. Remember, I'm still extending capital O object, right? So an empty, a class definition that does not include an extends clause is essentially equivalent in Java to this. So if I don't extend anything, I'm always extending capital O object by default. And so class, right? So let's look at this particular class, this pet class. Pet, again, it's easier maybe if we write out extends object. So pet can be a pet, right? I mean, a class can always act as an instance of itself. That's important. That's kind of what we've been looking at so far. But now we're going to focus on what else can it act like? What else can it morph into? A pet, because it extends object, can also be an instance of an object. And so a pet is an object, right? Every pet is an object. Every object in Java is a capital O object. That's why that method we wrote before, we could actually pass anything we wanted to that method and it would work. Now let's look, so any class that doesn't extend another class can be considered an instance of itself, but can also act like an instance of capital O object. And we'll talk about some of the rules behind this later. Now let's look at a class that explicitly extends some other class. So I have a dog class that extends pet. So every dog is a dog. Every dog is also a pet. And now I'm going kind of one level up. Every dog can also be considered an instance of an object, or every dog is an object. And so here, with some additional structure to the class hierarchy, I now have 3 ISA relationships for a class. Every class in Java, except for capital O object, will have at least one other ISA relationship because it'll be ISA object. But if you start creating class hierarchies, the deeper you go, the more of these ISA relationships you pick up. So now I'll look at this mutt class, which extends dog. So mutt extends, every mutt is a mutt, every mutt is also a dog because it extends dog, every mutt is also a pet because dog extends pet, and every mutt is also an object because dog extends pet extends object. And if I kept going and going, every level, every additional extend that I add to this class hierarchy creates a new ISA relationship as I get deeper and deeper. And so this is so these are the rules behind subtype polymorphism. This is the, if I think about an instance of a particular class, what are the different ISA relationships that I can establish? And that determines, what type of method can accept this. So if I have a method that can accept objects, like I just looked at, then I can pass a pet to it, a dog to it, and a mutt to it. And also a string and any other class you can create. If I have a class that accepts pets as a parameter, then I can pass a pet to it, a dog to it, and a mutt to it. But I couldn't pass a string to it because the string is not a pet. If I had a method that accepts dogs, I can pass a dog to it and a mutt to it because both of those have an ISA relationship with dog. But I can't pass a pet to it because not every pet's a dog. I can have a pet that's a cat or a lizard or whatever. And I can't pass strings to it because strings aren't even pets. Right? So now imagine I have a method that accepts a mutt as a parameter. That method can accept mutts, but it can't accept a dog, so not every dog is a mutt. I can have other breeds. It can't accept pets because not every pet is even a dog, much less a mutt. And it couldn't accept other types of objects like strings because not every string is even a pet, much less a dog, much less a mutt. So there's something about specificity here, and we'll come back to this trade-off when we talk about polymorphism again. This is one of those concepts that we're certainly not done with. We're going to return to it in later lessons. So this is, so now what we're doing is we're kind of establishing the rules, the rules of the game here. We see that polymorphism can happen, but now we're understanding the circumstances or the rules under which it can happen, and this is related to inheritance relationships. This is why we bring it up at this point in class. Okay, so now there's so I'm going to come back to that's a great question. I'm going to come back to it in a minute. So the question is there a way to prevent certain methods from being inherited? Well, if you mark them as private, right, then they're effectively not inherited. But any public or protected methods will be inherited, and they have to be, and that's actually really important, but we'll come back to talk about that in a minute. So now let's talk about sort of so now we know for a particular class what other ISA relationships does it have, and essentially what this means is that if I have a method that accepts a particular type of parameter, I can now determine what types of objects I can pass to that method. If I have a variable that stores a particular type of instance of a class, I know what types of objects I can put on the right side of an assignment, right? What types of classes I can put on the right side of an assignment. Those two things are completely connected. Now, the next question here has to do with method overriding. So, and this is another place where people sometimes get confused, and you might find this unintuitive, but actually there's a really, really good reason for this. So let's look at this example. I have my pet class, which defines a getType method. Now, this is a public method, and so this is connected to that question that somebody just asked, right? Which is, is there any way, if I extend pet, is there any way to opt out of implementing getType? Be like, I don't want to implement getType. I want to delete that method. We know that we can override getType. We can provide our own implementation. But the question is there any way to get rid of it? To refuse to implement getType? And the answer is no. And that is critical. And let's look at why, right? So now down here, I have a method called greetPet. This takes as a parameter an instance of a pet, or now we know anything that has an ISA relationship with the pet. So I can pass a dog to this, I can pass a cat to this, anything that extends pet. So pets obviously have an ISA relationship with themselves, but anything that extends pet can be passed to this. In this method, I am calling a getType method. The reason that I know I can call this method is because it's defined on pet and it's public. If that wasn't the case, so if it was private, I wouldn't be able to call it at all outside the class. So we can sort of ignore that case. But so let's say that my cat class could opt out of implementing getType. It could basically say, I don't want to implement getType. I'm not interested. Then there'd be no way for me to safely call getType on this pet parameter because I wouldn't know if the pet implemented getType or not. And so this is, how polymorphism starts to play a role in the types of access that we have to different instances of objects. So if a class implements a method and it's public or protected, then any method that takes an instance of that class as a parameter knows that it can call that method. Okay? Now either one of two things is going to happen here. Either I'm going to get the getType method from pet, or if the class that's passed to pet has overridden getType, then that's what's going to happen. And so this is where people sometimes get confused, right? So I have a dog instance here, and I have a cat instance here. So I've created a new dog and a new cat, and now I'm passing them both to this method that takes pet as a parameter. And so in both cases, I call it getType, but you'll see I see two different behaviors. When I call greetPet on the dog, I see getType return dog, and so that indicates to me that this getType method ran, the overridden method. And if I wanted to use my new cool annotations, I can put override on this. It works fine. So dog has overridden getType and provided its own implementation of this particular method that returns a string. Cat did not override getType, and so when greetPet calls getType on an instance of cat, what happens is I get the default getType implementation, or I get the implementation of getType provided by pet. And so what this means, right, is that think about what needs to happen here inside greetPet. Even though greetPet is treating a dog like a pet, because dog is a relationship with pet. Every dog is a pet because dog extends pet. Java still knows when I call this with dog on line 20 that the parameter pet contains an instance of a dog, because that's where it looks first for a getType implementation. So when you call a method like this, what will happen using dot notation is Java will start in the class that the instance actually is. It doesn't start in the class of the parameter, because if it did that, we'd see pet printed twice, right? So if I started looking in pet, I would find this getType method in pet and I would use it. Instead, what it does is it starts looking in the class that the instance actually is. So it still knows that even though the pet parameter is a pet, when I call it on line 20, it contains a dog, and when I call it on line 21, it contains a cat. So the first place Java looks for a getType method is in dog, and it finds this getType method, and that's what gets used. When I call it on a cat, it still looks in the cat class, but it doesn't find a getType method, and so it goes into the pet class and uses that one. But the reason that I'm allowed, so the reason the compiler allows me to call getType here is because it's positive that this call will do something, right? It knows that I can use dot notation to call this method. The reason for that is the method is defined on the pet class. Now let's see what happens. Let's say class animal, and let's make this empty, and we'll have pet extends animal. And now let's have our greetPet take an animal. Now I can't call this method, okay? And this is, there are these I know sometimes it just seems like such a small difference, and people are like, whatever, right? But this is one of those, there are these really small differences between pieces of code at this stage of what we're trying to teach you that I really want you to kind of reflect on and think about, carefully. So why can't I call getType now? Because not every, well, first of all, if I pass an animal to this, let's say I say animal is equal to new animal, animal doesn't implement getType. So if I call greetPet with an animal, there's no getType method, right? And even if animal, so if I put a get type method on animal, I'm fine. In this case, the only known subclass of animal is pet, and pet implements get type. And so you might wonder, like, why doesn't Java know that? But who knows? Somebody might come along in a minute and implement a new descendant of animal that doesn't have a type. And so at that point, this code would fail. So in order for the compiler to be able to be willing to compile the code and produce bytecode, it has to know that there's a get type method available anytime greet pet is called. And the only way to do that is to make sure that that method exists on the type of the type of the parameter to the method. So now again, I can, oh, now it's angry about this. I gotta get rid of my animal extension. And now I have this other problem. There you go, yeah. So and so that goes to the question which someone asked, but it's a fantastic question. So, is there any way, again, to opt out? No, there's no mechanism for doing that. And that would really kind of destroy the benefits of polymorphism here. So, polymorphism and Java's inheritance mechanism sort of give us this nice mixture of features, right? Where when an object extends another class, it inherits all the state and behavior from that other class, all the public state and behavior. If it wants to change stuff up, like if there's certain parts of that class that don't work, it can override them. It can provide its own implementation. If it does that, then those are the implementations that get used when that instance of the class is used, in this case, when it's passed to pet. But if it doesn't need to override them, it just uses the default, right? And so it's this nice combination of safety, because I know that every pet's going to have a get type method, but also flexibility, because if pets need to change the behavior of get type somehow they can. Now, we're actually just scratching the surface in terms of the different types of class design mechanisms that Java provides. There's lots of other, ways to, so for example, if I make this method final, then, so you might say, well, what if the parent class wants to prevent the child from overriding the method? I can do that. So I can mark the method as final, and then my children are not allowed to override it. They still inherit it, but they cannot modify it, right? And so now you'll see that when I put this final keyword on, and this is not something we've covered, I just thought of it, and so I thought it'd be interesting to point out, right? So Java provides lots of control for class designers, for you, the programmer, the creator, to set up your class in ways that work. And there's times when it's not safe to allow the child to override a method because I really need it to work a certain way, right? And so in that case, I can mark it as final, and the children can't or any of my descendants, children or grandchildren, can't override that method. Great question. All right, so now let's look at casting. So the question is, when I have these is-or relationships, so what Java will do is it'll automatically, so we saw this when I passed something to an object, to a method that accepted object. I took something that had an is-or relationship with object, and I was able to cast it to an object automatically when I called the method. This is sometimes known as upcasting, because I'm taking a descendant and I'm casting it to one of its ancestors. So I'm casting it to its parent or to its parent's parent. And one of the reasons I can pass anything to a method that takes a Java object is that everything in Java can be cast to a Java object, because everything in Java has object either as its parent or its grandparent or its great-great-parent or great-great-grandparent. It doesn't matter. If I keep going up the hierarchy, I'm going to find capital O object eventually. And that's actually where I'm going to stop, because capital object is the only object in Java that has no parent. Java will automatically do this type of casting for me. So you'll see here, let's look at this assignment. So we've seen this when I pass an instance as a parameter, but I can also do this in an assignment statement. So here's the kind of assignment that we've been used to seeing so far, where I have a dog, I have a variable that can store a dog on the left, and I create a dog on the right. So I assign a dog into a variable that can store a dog. But because dog has an is-or relationship with pet, a variable that can store a pet can also store a dog, because every dog is also a pet. And so I can create a variable called pet, and I can store a dog into it. Same thing with object. Every dog has an is-or relationship with object, because an object is dog's grandparent. And so every dog is also an object. And I can so I can assign a dog into an object. Now, the video here, and I'm not going to go through this, well, I probably should, right? Let's see here. Let's create a void method called woof. And this void method doesn't need to do anything. And then I'll have pet have a void speak. Okay. So now what I've done is every pet has this speak method, every dog has this woof method. These methods don't need to do anything right now because what I'm going to show you only requires the compiler to check things for us. So if I've got a dog, then that dog can woof. Compiler's happy with that. That dog can also speak because it's a pet, and that dog can be converted to a string because it's also an object. Every dog is a dog, so it has a woof method. Every dog is a pet, so it has a speak method, and every dog is also an object, so it's a toString method. Okay, now here's where it gets interesting. So let's take this, and let's try this with pet. Now remember, my pet is a dog. The pet variable can store any type of pet, but it's currently storing a dog. I assigned that way on line 11. And let's see how this works. Okay, now I've got a problem. I can't call woof on my pet variable. Why not? Because not every pet can woof. If I have a cat that extends pet, it may not have a woof variable. And so the problem is, if my pet variable contains a dog, then maybe it's able to woof. But if it contains a cat, it definitely can't woof. Cats don't have a woof method. Okay, so when I have a variable that can contain a pet, I can only call methods on it that I can call on any variable that can contain a pet. Now, every pet can speak because that's a method that's on the pet class. And every pet can also be converted to a string because that's a method that's on capital O object. So I can call these two methods. Okay, you can probably see where this is going. There's some nice sort of symmetry, nice pattern to this. Let's try this with my object. And we might as well do all of them, right, just for fun. Now keep in mind, this object is still a dog right now. I initialized it that way on line 15. But I can't call woof. Why not? Because not every object can woof, right? Like, pets can't even woof. Not every pet can woof, okay? So I can't call woof. Can I call speak? No. Not every object can speak. What if I make an object in, what if I reassign this object to a string? Strings don't have a speak method. Okay, can't do that. Can call toString. And so essentially you can think about it this way. When I upcast an object, it loses the features that it had before. When I upcast it to store it into a variable that can store an object, it can only use the methods that every object has. In this case, if I store it into a method that stores a dog, if I store it into a variable that can store a dog, I can use all the dog methods. I can do woof, I can do speak, because every dog is a pet, and I can do toString. If I store my dog into a variable that can store a pet, now I'm limited to only the methods that I can call on every pet. And that's speak, because every pet can speak, that's part of the pet class, and toString, because every pet is also an object, has that method. If I go one step farther and I assign my dog into a variable that can store objects, now I'm limited to only the methods that every object has. So I can call toString, kind of it. There's a few others, and we'll come back to those later. Okay. Yeah, and so I've basically done these two. Now, so let's see here. I can probably, right. So now you might ask, is there any way to determine when the code runs what is actually stored in there, right? I have an object instance. Is there any way to figure out like what's inside, right? And specifically, you have cases where I might have a couple of different types of pet, and maybe I have a method that I want to be able to call that method on any kind of pet, but I want to be able to determine what type of pet it is. And I might know that there's a few options that I need to have some maybe be able to treat special. And so Java has this what's called the instance of operator. And you can see this here. So for example, I can say, let's say I store a dog into my pet. I'll run this. It actually have to get a spell. So this operator the way it works is it evaluates to true if the variable on the left stores something that has an is a relationship with the type on the right. So anything that's a dog, or if I extend dog, let's say I say class mutt extends dog, let's say new mutt, also returns true. So this essentially, it returns true if the variable on the left contains an instance of a class that can be upcast to the variable on the right, to the type on the right. Sorry, what's on the right is a type or a class name. In this case, it would also be mutt, but if I change this to dog, then it's false, because now every dog is a mutt. If I use object, I might even get a complaint here. This is always true. So anything in Java, every object can be upcast to an object. I can use this in my code, and there's places, particularly tomorrow when we talk about how to implement object equals methods, there are places in Java where you have to use this, particularly when you're trying to determine if two things are equal. But this is the way to determine if a variable, now you might wonder, like, how is this evaluated? So this is actually something that's evaluated at runtime, because what's inside pet can change, right? So for example, I could do something like this. I could say pet is equal to new, let's use this, and we'll say for I is equal to 0, I is less than 32, I plus, and we'll say if random.next boolean. So this essentially gives me a random boolean. I'll say pet is equal to new dog, else pet is equal to new cat, and then I'll explain what this is doing in a minute. Pet instance of dog. Dig. And then I need to run this. Oh, I gotta get rid of my duplicate declaration here. Oh, I need to import random. Import random from Java type. Sorry, I'm doing some things in here that we haven't seen before, but this will make sense in a minute. Good Java. Okay. There we go. Okay. So what is this code doing? This code is essentially every time I go through the loop, I'm choosing randomly whether to have pet referred to a dog or a cat. And again, you can ignore some of the other things we've done here. We'll explain some of this stuff later. But what I did is I basically wrote some code, and now when I get to the statement, I don't know whether pet contains an instance of dog or not. It depends on the coin flip that I did in the line of code above. And so this is an operator that's evaluated when the code runs. Can I? Yeah. So the question is, can I do this? Absolutely. Yeah. We're essentially doing this right here, right? Why can I do this? Because a dog is a relationship with pet. So every dog is a pet because dog extends pet. So I can save an instance of a dog in a variable that can store a pet. I'm trying to think of a good metaphor for this, but I can't think of one. Yeah, I mean, there's probably some physical metaphor for this, but this is sort of how this works. All right, so that's pretty much it. There's definitely some more information in the walkthroughs that I would encourage you to check out that you'll need to do the homework problem. Questions? Like I said, this is the last couple of lessons are, I think really probably some of the trickiest conceptual material that we'll look at, particularly with respect to objects. We're going to go on. We have several more weeks to enjoy objects together, and we're going to talk about some really neat object-oriented concepts starting next week when we talk about references, and then the week after when we talk about interfaces, which are really neat ideas and very, very powerful ideas in computer science. But this is kind of one of these places where there's a little bit of a steep section in the learning curve. So questions about this stuff. Tomorrow, we're going to, definitely start to integrate, slow down. Friday, very much so. Tomorrow and Friday will be lots of review. One new idea maybe just to talk about tomorrow that's really a way of applying some of the things that we already know. And then on Friday, we're really just going to kind of do an example together where we use some of these new inheritance features to do some, to kind of do some interesting programming of some kind. So questions about about this material? Great question. Can I add methods to big O object? No, well, I mean, I guess the answer is, well, the simple answer is no. The more complex answer is sure, right? First, you have to get a job at Oracle, and then you have to figure out a way to get them to hire you into the Java core team, and then you have to, get access to the code that implements object, and somehow convince people there that you should add a method to object, and then you can do that, right? But I don't think that's what you were asking. I think what you were asking is, can you, as a humble programmer, add a method to capital object? The answer is no. This is it's a very interesting question, though. So there are, now on some level, there are some really nice things about that, because whenever you use object, you know what you're getting, right? If you could add methods to object, that wouldn't necessarily be dangerous in and of itself. What is particularly dangerous is if you could modify the object methods. So let's say I can take some default object methods and make them behave differently. That would be bad. There are programming languages that essentially allow you to do this. JavaScript, for example, has a feature that allows you, if you want, to essentially modify the way that certain built-in parts of JavaScript work in a way that affects all of the code that's part of your project. Not all the code in the world, it's just the stuff that's part of what you're building. That's typically considered to be a mistake. On the other hand, one of the cool features of a language called Kotlin that I really like is that in your project, if you want to add methods to an existing class that you don't own, right? So if you own the class, it's like, go add the method. It's right, the code's right there, right? Like that's on you, right? If you want to add a method to a class that you maintain, by all means, you're the designer, you're the creator, do it. Usually what happens is, like, you have a method for some, you have some other feature that you wish strings did, for example. It's like something that would be useful in your project and you wish that strings did that. Now, you can always write a method that takes a string as an argument and returns the result. But part of what's cool about object-oriented programming is this idea that whenever I have a string, I can just call the method using dot notation, right? Kotlin has this feature which are called extension functions. And what extension functions allow you to do is, and maybe, since we're almost out of time, I'll just show you this because this is a really neat feature of Kotlin. So where, I think it probably isn't here. Anonymous functions, function closures, function types, trailing lambdas, extension functions. Yeah, so here's an example. You guys can see this. Let me blow this up a little bit. So what Kotlin allows you to do is allows you to say, hey, let's say I have some function, like let's say, for example, I want to be able to determine whether or not a string contains an Illinois email address. So one way to do that, obviously, is to just write a function, and the syntax here is a little different than you're used to seeing, but I suspect you can probably puzzle it out, right? Well, actually, this is Java, so this is how you would do it in Java. I would just write a little method. What I can do in Kotlin is I can actually, I can create what's called an extension function. And what this does is it makes it look like strings have this new function. So for example, now I can call this function on an instance of string. This is not a real string function. Strings will actually have the validate email function. But in my project, if that was useful to me, I could add that, and then I can call it using dot notation. Now behind the scenes, what's happening in Kotlin is that it's actually creating something a lot like this. So it's actually creating a function that takes a string as an argument. But from a syntactic perspective, you might argue that this is much more satisfying. Now, an important thing to keep in mind is that this is only part of your project. So when I write this piece of code, this doesn't add a method called validate email to string that's available to everybody. Again, if you want to do that, you got to go work for Oracle. Or start working on the OpenJDK or something like that, right? But I suspect, it's a great question actually. I don't know, I think it's really interesting, like why some of these things change over time. So I noticed recently, for example, and again, let's pull up the string documentation for the latest version of Java. Although actually the latest version is Java 15, which just came out. But I'm still on Java 14, which didn't come out too long ago. So look at this, okay? This is a method called repeat. It repeats a string a certain number of times. This was added in Java 11. Do we need this function as a part of a string? I don't know. I mean, I feel like it's a little silly. I mean, not that this isn't useful, but I feel like once you have a repeat function, I can think of like 10 other functions that you could add that, would also be semi-useful. But, so there's this tension in any language, right? Particularly an old language like Java, which is kind of like, when do we add new stuff and what's worth it? Like, if you look at libraries for doing string processing, they have lots and lots and lots of other functions that aren't part of the core string class. But for some reason, Java decided to add a repeat method like a couple years ago, right, to strings. I don't know why. This just doesn't make a lot of sense to me. I mean, partly because this is a very, very easy method to write yourself, right? And so anyway, but yeah, so there are languages that allow you to do something similar in a way that allows you to use dot notation in a way that's sort of elegant. Java doesn't do that yet. Maybe it will someday. I don't know. Be interesting to see if they decide to do this. But for now, if your options are, if you control the source of a method, if you control the source code, if you're the creator of a class or you're part of a team that's created the class, yeah, add away. If you don't control the class, you don't really have an option. Another thing you can do sometimes, not all the time, right? Let me just jump up here, right? Is you might have, like, let's say you have some extra functions that you want to add to string. And so you might try to do something like this, right? You might say, hey, I'm going to extend string, and then I'll add that Boolean validate email function, and I'll say, then I can do whatever, right? The problem here is that, well, let's see here. Why is it angry with me? Oh, sorry. I need a class. Yeah. So this is another, Java feature that we haven't talked about that is involved in class design. The string class in Java has been marked as final. That means that you cannot inherit from it. So there's no way to extend string and create your own stuff. Now, if you could, then you could do stuff like, my string, string s is equal to new string, whatever, and then you would have access to any of those new methods that you added to your myString class. Oh, sorry, you still have to create myString, but you can't. And this is actually one thing that I don't know what the answer is. Maybe I should Google and see if I could figure it out, right? But I don't know why string is final. Again, that's a decision that's up to the class designer. So when you create a class, if you, for some reason, do not want people extending your class, you can mark it as final, and then nobody can inherit from it. That class is essentially kind of a dead end. So really, really cool class. Java card. What is Java card? Somebody needs to clarify that question. Or maybe I'll Google it. Java card? Oh, no. No, that seems interesting, though. I'm assuming that this is what people are talking about. Is this still a thing? Huh. Let's see here. Oh, well, I guess they did this. No, we're not going to do anything with Java card. It's interesting. I didn't even know that this existed. All right. So a question about upcasting and downcasting, and actually we'll come back and talk about this more. But the question is, why would I think the right way to ask the question is, what's the point of upcasting if I lose functionality? So there's kind of like, the way to think about it is sort of like a triangle, right? As I upcast, my method can work on more objects, right? So let's go down and let's look at this stupid method that I wrote here, print it. Every Java object has a toString method. And so this printIt method can now be called on any Java object. That's super cool. So I get generality, essentially. So there's this trade-off. As I make my method accept more and more general types of objects, it can be called on a much, much larger number of Java classes. So again, this method can be called on any single Java class, the ones that already exist and any ones that anybody designs in the future. And the reason is it only uses features that every Java object has. Later in the class, so one thing we're going to do in the last part of the class, which is really my favorite because we get to do some algorithm and data structure design together, we're going to implement a list in Java. We'll show you how to use a list, which is really cool, and then we'll implement a list together in a couple of different ways. We'll talk about the trade-offs. One of the things that's cool about a Java list is I can implement it in a way that allows it to store any type of Java class. And the reason for this is that there's only like one method that I need from object in order to implement a list properly, and that's equals. The same thing when it comes to a map. So some of you that use Python or other languages are familiar with dictionaries. You might wonder, does Java have a similar feature? Oh yeah, every programming language has one of these, and we'll show you how to use it, and we'll show you how to build it, which is fun. Same thing with maps. I can create a map that allows me to use any Java object as a key. That's kind of what you store. There's a key value pair stored in a map, right? You can think of the key as sort of like an array index, except it can be anything. I can create a map that allows any Java object to be used as a key and a value. And the reason is that every single Java object has hash code. So that's another one of these methods that we turn out to need later in order to do this. So if you create your methods and your data structures in a way that allows them to be as general as possible, then you can run them on many, many, many more different types of Java classes. If you create your methods to be more specific, then you limit the number of things that you can do, right? So for example, if my method takes a course object instead of a capital O object, now I can do the things I can do with the course. So I have access to more information about the course, but I have the method can be called on fewer classes. And so there's a sort of a natural trade-off here, right? As I upcast, as I get higher on the tree, the number of objects that my method can be called on increases. As I downcast, the number of classes that I can be called on increases, but the number of methods that I can use decreases because I'm losing all of those class-specific methods as I'm going up the tree. As I go down the tree, I gain access to those class-specific methods, but I lose access to different classes, right? So again, if I call this on a course, I get access to all the course methods, but I can't call it on a capital O object, any other type of object, right? And so there's this trade-off between power, generality, right? Power meaning access to more class methods, generality meaning the ability to work across more classes. Usually there's a pretty natural trade-off here, right? I mean, usually what I would say is try to make your method accept as many different types of objects as possible. Now again, you don't have to, the number of methods that actually need to work on a capital O object is pretty small. But like I said, there are some cases in which it's incredibly powerful. So when we create a list, you know, it would kind of be strange to create a list that could only store a certain type of object. In some cases, we might do that because the list might work in a way that requires some information about that particular type of object in order to optimize it or something like that. But usually when we create containers in Java, like lists, we want them to be able to store any type of class. And so what we do is we restrict ourselves to using features that only Java objects have, which turns out to not be too much of a problem. That way, your list, your container could store any type of Java object. But it's a great, I mean, this is a great question. I mean, there is this, you know, computer science is full of trade-offs, right? That's one of the things I think is really fun about the field, and that's what makes it a design field rather than an engineering field, in my opinion, right? Are these, well, I shouldn't say that. Engineering has plenty of trade-offs too, but you know, computer science, you have these really fascinating trade-offs in a lot of different areas, and this is one of them. So, great question. Java. Yeah, so Java card looks like this little sort of embedded device thing. Yeah, we're going to do Android. We're not going to do Java cards. Java applets are a fascinating story of a misbegotten technology, though. So I'm you know, certainly at some point, maybe I'll have office hours or something, and we can talk about Java applets, which are really kind of an interesting. Most of you don't remember them, and it's actually really hard to show you what they were like because most browsers don't allow you to use them anymore. But Java applets were a very, very early attempt at making the web more interactive. So you go to a web page and there'd be this little Java applet embedded in it. You'd sit there for 10 minutes while it loaded up, and then they're super ugly. Actually, let me see if I can find a Java applet to actually show you. I don't think you can. I don't think you can. I think they're gone. Let's see here. Applet development examples or described. This is probably not going to work. Oh, maybe it, yeah, see, there we go. Java plugin is not supported by this browser. These used to work, but it's been a while. Card seems like it uses some of the old Applet technologies, which is interesting, but it's not something that we talk about in this class. But you know, at some level, it's all Java, and this is one of the things that's cool about Java as a programming language, is that once you learn it, you can, you know, build web server applications, you can build Android applications, you can build embedded applications that run on Java Card. There's just a lot of places in the real world where Java gets used. You can build desktop GUI applications, although I wouldn't suggest doing that because I don't think those applications are the future, but whatever, right? So Java has a lot of different uses. All right, that's our, I don't know if I'll have office hours today, maybe. I'm sort of trying to do those on more of a surprise basis, so maybe tomorrow, but we will have details out about the machine project probably right about mid-semester. I think that's when we're going to release it. We're going to build a small Android app together, and we're going to try to show you some design patterns that work for Android, and you know, just kind of get you started with some new things that we don't really. The machine project kind of tries to do some stuff that's complementary to what we do on the homework. So you'll do some networking. You'll work with a slightly bigger code base. There'll be some things in there that you're going to puzzle over, and you know, there's some things about Android that are a little tricky to wrap your mind around, but will help. And so we'll get that started in a few weeks from now. All right, great to see everybody. Hope see you again tomorrow. Take care of yourself.